Let's solve this allocation problem with the Hungarian algorithm. We look at each row and determine what is the lowest value in that row, and we're going to subtract it from every value in that row. Now down here, I filled out the table with that subtraction. So 2 minus 2 is 0, 5 minus 2 is 3, 7 minus 2 is 5, etc. We now want to check if we can put lines, horizontal or vertical lines, that cover all the zeros. Now we could go like this. That covers all the zeros, 4 lines, but it's not the minimum number of lines. So let's try and cross off as many zeros with a single line. Next we can put 2 like that, or alternatively we could have done vertical lines. We have 3 lines, and that is not equal to the number of allocations. We need 4 allocations, W, X, Y, and Z. So we have to keep going. What we're going to do now is subtract the smallest value from each column. We did rows before, now we do columns. But we're only doing it to the non-zero column. If I had have put lines like that, we'd still look at the column and say, let's subtract the smallest value. So we're going to subtract 3. So let's fill out our table again. Everything stays the same except for that column changes. It becomes 2, 0, 4, 0. Now let's try again with our lines. Let's put this vertical line, let's do that one there, that one there. We still only have 3 lines, so we have to keep going. Our next step is going to look at all the numbers that don't have a line through them. No matter how you've drawn the line, this will work. The lowest value there is 1. So we're going to subtract 1 from all these numbers, all the numbers that I've circled. So we have 2, 1, 1, 0, 3, 2. And the other thing that we need to do, look at where our lines intersect. And we're going to add 1 to those. We subtracted from the uncrossed numbers, and here, the doubly crossed numbers, we add 1. So 0 stays the same, this becomes 3, 0 stays the same, this becomes 4. And then everything else is the same. Now let's try again with our lines. We can put this one, this one, this one, and we have to add another one. It doesn't really matter how. So 4 lines, 4 allocations. We stop. Next, where there are zeros, we have edges. So all these zeros are going to turn into edges. W, A, X goes to B and C, Y goes to A and B, Z goes to C and D. We now connect W to A because it has to go there, therefore Y has to go to B, and X has to go to C and Z to D. So we have our allocations and we can write those down. We then use the original table with the cost values to determine the cost of each of these allocations. So we write those in. WA is 2, XC is 11, YB is 6, ZD is 6 as well. And then we add up those costs, and that will be our total cost for these allocations. And these are our allocations.